Hello, everyone, and welcome to the HostBridge Technology webcast. I'm Farrell Johnson, and I'm the Director of Business Development at HostBridge Technology. Today's webcast is about how to find and fix inefficient mainframe integrations. We will highlight three primary causes of poor hybrid cloud mainframe application performance. A little housekeeping before we get started. We are recording the webcast, and we will post this on our YouTube channel. We'll also email a link to the recording of the webcast to everyone who registered to attend this event. During the webcast, we'll have the phones muted, but we'll periodically, as we can take breaks, unmute the phones for questions, or please use the chat or question and answer options to post questions, and hopefully we'll reserve time at the end to answer questions and have more dialogue. Our presenter today is Russ Tubner. Russ is the CEO and co-founder of HostBridge Technology. For over 4 decades, Russ has applied his creative energies to solving difficult problems associated with integrating large-scale IBM systems and various emerging technologies. He has done pioneering work in the integration of IBM mainframes and applications with Unix systems, TCP/IP networks, facsimile transmission networks, the World Wide Web, and service-oriented architectures. Russ is a frequent contributor to various technical publications and has authored several U.S. patents. And with that, let me hand off to Russ.
Farrell, thank you very much, and welcome to everyone. Thank you for that generous introduction. I haven't done anything with facsimile systems in a long time, that's for sure. But we're here today to talk about some interesting topics, and I really like the way that Farrell teed up this topic about finding and resolving inefficient patterns of integration. Now, what we're going to focus on today is really far more of the finding aspect of that. And we're going to highlight some technology and some work processes that we've been developing over the last couple of years, very much arm in arm with our customers, to create a way that they can actually see, detect, find, and evaluate inefficient patterns of integration with predominantly, generically, anything running on the mainframe, but we're going to focus on CICS-based transactions, CICS-based apps. Just to know where we're coming from, I mean, I can see from the guest list, there are many people who know our company well, and some of our customers. Thank you very much for taking your time to be here and for the privilege of serving your organizations. And there are a nice mixture of new faces, new names. We are HostBridge. We have been around well over 20 years now, focusing on the difficult integration problems that our customers face. All of our customers live in a hybrid environment. All of them want to be able to squeeze the last bit of value, or not just last bit, but ongoing value out of their investment in System Z-based apps. But they want to do it in a way that gives them performance, that gives them agility, that gives them modernization momentum going forward. And so while we have many customers in banking, insurance, and manufacturing or logistics, we certainly go beyond that. So our customer base, broadly speaking, is not defined by a particular industry category, but by any organization who is using System Z, running apps on System Z, and want to make sure that they integrate the apps and the data on System Z to their hybrid world as efficiently as possible. So let's dive in. There are a lot of warning indicators about whether or not poor integration might be in the way. So how do you know? Well, there are a number of things. This is sort of like, for lack of a better analogy, the COVID test for potential poor mainframe integration. Long user wait times or delays when accessing data Mainframe apps and data are astonishingly fast, and when end users or distributed applications start to experience inefficiency or long wait times or delays, that's usually an indication that there may be some poor integration under the covers that needs to be surfaced. Also, the inability to scale transaction volume. We have a number of customers who are just constantly on a treadmill where they go through a mainframe capacity upgrade, but lo and behold, the scale of their business sucks that new capacity far faster than they expect or wish it would. Also, another way of maybe saying the first bullet here is what we would refer to as end user service denials. And that is, there are many organizations that during the peak period of their processing day, it's during that peak period where end users are really experiencing the most difficulty getting their work done. It's affecting their productivity and the organization's productivity as a whole. Those are just some, but certainly not an exhaustive list of some of the tests, the indicators that there may be some poor integration under the covers. Another way to kind of look at this really goes back to the start of our whole journey in this domain. I had a friend call one day, and he asked the one question that if you call and ask me, it will just make my day. He teed up a problem. He said, here's my reality, Russ. Our business is growing nicely, but our mainframe transaction volume, as our business continues to grow, the transaction volume is scaling asymmetrically to the underlying business volume. He said, he went so far as to say, if I even put a pencil to it, where we are right now, I'm not even sure if some of that incremental business volume is even profitable, given what's happening on the back end in terms of this asymmetric growth in transaction volume. And so I said, well, what would you like? I mean, what does the solution look like to you? And he said, well, obviously, what I'd like is a dotted line that looks something like this, where my mainframe utilization tracks more closely with the business volume. Now, this might be a bit optimistic to say that, mainframe utilization stays flat as the business volume grows, but you get the idea. Anything is better than asymmetrical growth as your business grows. So what we decided to do was, with this customer and a number of other customers, is go on a journey to really figure out how can we identify, evaluate, and mitigate inefficient integration. Now, the first step is identification. And when we looked at what our customers had to even attempt identification of inefficient patterns of integration, there just wasn't much there. And it's kind of understandable. And that is that most organizations have really good tooling to zoom in on that, the distributed part of their organization, where they have all of the devices, whether they are in the hands of internal users or partners or customers, or whether or not they're exploring the use of RPA bots, automated hands, so to speak, on the keyboard. But they have reasonably good tools to be able to look between those square brackets and say, oh yeah, I kind of see what's going on there. They also have pretty good tools to zoom in just straight on the mainframe. Most of our customers, and I'm sure you do too, you have tools that you can say, you could probably pull up TMON or SysView right now and tell us, how often transaction XYZ ran in the last 30 minutes, how many average IOs it consumed, how much CPU time on average it consumed. and you can get into the weeds of those individual transactions really quickly and carefully. But what we are talking about, or what we need to do in order to suss out, to discover inefficient patterns of integration, is we need something that can kind of look at the whole, that can look at the forest, not just the trees, and analyze, okay, what is all this traffic? Okay, I am running 20 million times a day, transaction XYZ. Why? Do we really know the business value of how that's happening? What's really driving that workload? And in a lot of organizations, the reality is they don't. Now, we decided as a result to create a framework. And the framework will be used as part of the demonstration that I'll be showing you in a minute live. But I want to make sure that we're at least clear on how it is this framework works. We sat down with the set of requirements from our customers a couple of years ago and said, okay, how do we gather enough information about all of this request and response activity coming in and out of Kix to be able to deduce what's really going on here? What's the pattern of interaction here? And so we decided to create a framework. And the beginning point of the framework are a collection of very fast and efficient Kix exits. And what these exits do is very specific. They look over the shoulder of each and every targeted request sent into the mainframe, and we extract from it a few bits of metadata. And the metadata is simply to let us understand the business context in which this request is occurring. Is the running of transaction ABC coincidental with XYZ? Are they part of an automated flow, perhaps driven by an Excel macro or a screen scraping script or an RPA bot or whatever? So we grab a little bit of metadata, and then we cause that metadata, or we allow it and do go through the proper steps to enrich your SMF 110 records. Now that's really pretty big, honestly, just being able to get that level of enrichment in the SMF data. But in order to really do analytics on it and apply some degree of machine learning and a little bit of light AI to it, we wanted to get that data down to a proper analytics platform. And today we focus on Splunk. And so the demonstration that I'll be showing you, you'll be seeing me operate a set of dashboards with this data using Splunk. Now, at this point, I usually get a couple of questions about, well, do you only support Splunk? And the answer is today we are focused on Splunk. However, I am very interested in talking to customers or prospective customers about whatever preferences they might have. As a result of some of those conversations, we are beginning to take a look at other platforms such as Elastic. But full disclosure, today we are focused on Splunk because it gives us everything we need to be able to help our customers find their integration issues quickly and then be able to visualize them and be able to connect the dots. And that's really what we're about. That's really what this offering we have that goes under the banner of HTAC. It's called the HostBridge Transaction Analytics Connector. I kind of regret using that connector word there because it's sometimes misinterpreted. This is not a connector as in, just connecting your mainframe to Splunk. No, not at all. This is about connecting the dots, being able to see the full picture from where the requests are being driven from. Let's say it's an RPA bot or an Excel macro, all the way to the mainframe, and being able to connect the dots and see that pattern of integration and be able to evaluate it for its efficiency or, honestly, the lack thereof. Now, I'm going to go ahead and move into the live demonstration here. And so this is the moment where I kind of hold my breath while we get everything all set up here. And I want to go ahead and I'm going to go ahead and get a couple of things prepped and ready. And what I'm showing you here is a Splunk. Splunk. It is a set of dashboards that we have authored and provide either to our customers for their on-premises use, or we do this as a service as well. But what we do is when you send us your data, we run it through a whole battery of analyses. And it never fails that one of the most interesting analyses that we perform is looking at what we would call macros, or robotic process automation activity. So in this dashboard, we title it's the RPA, or macro impact analysis, because what this dashboard does, and again, this is certainly one of the more compelling dashboards, but it's not the only form of analytics we do with the SMF data. But it tends to be the one that captures the imagination of our customers the most and helps them see actionable problems that they can fix today or tomorrow or next week. So we're going to focus on, in this dashboard, on these macros that are driving lots of terminal-oriented or screen-oriented transactions. Now, your mileage may vary compared to these two customers, but I can almost promise you, or at least I can, based upon the data we've seen from a growing set of customers, most organizations have problems like this to some degree. Now, in some organizations, for example, the two I'm going to show you right here, it's a killer. Others, maybe it's just a nuisance. But what we're doing here is, and I'll scroll down now, we are looking at some data that came from a customer, and we are looking at their RPA, or macro activity. And we are looking at, for example, individual days. So on February 15th, 2021, we were able to deduce that 1.6 million transactions were executed as a result of running 21,000 macros, or RPA bots. From that, we deduced 2,293 unique signatures, about 1,000 unique users, and about 1,000 endpoints that were doing this activity. Now, we also lay that out in a series of time charts here, where we can go and look at a particular day, and then we'll break down that day by hour so we can see the highest impact moment. And we could see in this organization, it was at 9 a.m. Their top hour, there were 2,282 macros, or RPA bots, that were active against this set of KICS regions. And we can actually drill it down to the minute, because it turns out that this activity is something that many organizations need to correlate with other operational problems. Because in many organizations, when these sorts of macros or bots fire up against their KICS applications, it causes a lot of other problems on the back end. So we can drill down, for example, to that highest minute where we had 71 of these things active. And now we can see exactly what's going on. Now, granted, since this is your first view of one of these screens, I'm going to walk through it just a little bit to help you decode it. And that is that what we know from this analysis is that is the name of the endpoint within the VTAM network. That is a PC running a terminal emulator. And that terminal emulator, I know from this customer, is being driven by a set of Excel macros or other RPA components, either running on a client or on a desktop. We know a lot of things about this activity. and we've been able to suss out that it started at 9:59:59. It ended at about 10:02. Doesn't seem like a long time. It only took three, so it took 3 seconds. That's not very long in the big scheme of things. We'll see much longer ones in a moment. But the interesting thing to note is that this activity that took 3.5 seconds under the covers of the mainframe only took 203 milliseconds. So let's just stop there. This is a business process, whatever it is, that the way it was orchestrated using a bot or a macro took 3 seconds. The underlying activity was sub-second. All those transactions ran in a total duration of 203 milliseconds. And that's how we get this duration ratio to help you see and understand these sorts of factors. Now, and where does this come from? Where does all this this time go? Well, 8 times out of 10, it goes to the network latency between the endpoint and the mainframe. And so it's important to keep track of that. So for example, here's one. The RPA took about 13 seconds. The underlying transactions took 300 milliseconds for a 42-to-1 duration ratio. Now, we'll look at some other very interesting use cases in a moment, but I'd like to just help you see and get a vision for what we're doing here. So now these are very simple macros. Well, in fact, let's go down to here. Let's look at this one. This macro executed 51 transactions, and we can tell you exactly what it did. So this macro executed the ORR transaction, pressing the PF3 key. Then it went to the ORC transaction, again a PF3, ORC, ORR, and that *2 after the enter means that happened twice. And we can just walk through. Now, we call this the DNA of the RPA, or of this robotic activity going against kicks. Now, what we do is once we have created and essentially extracted the DNA of this activity, we give it a signature. And a signature is simply, it's algorithmically, it's just an MD5 of certain factors related to this. But by doing that, we're able to look for common use cases. In other words, what are the most frequently executed signatures? Is it this one? Or is it this one? Or is it none of the above? So let's go back over here, because that's really the key question. And that is, what's really impacting your mainframe? And let me turn on the Paretos here and give you a bit of an explanation of that. So what we also do on this particular dashboard is we grade out all of this RPA or automation activity that is going against your mainframe. And we've tried to make these charts such that you can really hone in on your worst case offenders. So now this chart here, total CPU time versus total duration for given RPA signatures, whatever dot like this one is in the upper right-hand quadrant represents the highest combination of total duration and total CPU time. Let's see what that is. Now, I happen to know the answer to what that is. And I can tell you that when the customer saw this the first time, their jaw sort of hit the table. And the most common DNA of this automation activity is what? They are scripts or bots or macros that are camping out on an individual transaction, pressing the enter key multiple times, waiting for something to change. Now, I'm going to sort this in descending order by RPA total. In other words, and RPA total is the number of transactions that this bot or automation took. Now, let me highlight that this bot, this macro that we're looking at, ran for 22 minutes. The total transaction duration, the total duration of all the transactions it ran, all 10,000 of them, was 1 minute and 33 seconds. So, and what did it do? Well, if you look right over here at the DNA, this is a transaction. This is a bot that simply camped out on a given transaction, ORR, and pressed the enter key 10,503 times at a rate of 7.8 times per second. Now, and you can see the sum total of all the CPU time, the CPU seconds that are being consumed by this activity. So obviously, the customer did not expect to see this. And so the question, and good, so it really surfaced some unique, interesting things here. And now the question is, why is someone doing this? Why did someone write a script or a macro to pound the enter key in an automated fashion, waiting for something to change? Well, it turned out that, people don't write macros like this to be nefarious. They write them to accomplish some business purpose as best they can. And in this case, this macro was written by someone in the technology side of the sales organization, to allow a sales representative to know when an order status changed. So for example, when an order status changed from pending to accepted. And how did they choose to solve that problem or gain that insight? Well, they chose to write a macro. They are going to get on a particular screen, and they are going to press the enter key however many times and however long it takes, every 200 milliseconds, until the order status changes. Now, I think all of us can agree that this can't be, in the modern world, it can't be the best optimal way to let sales professionals understand when an order status has changed. Surely there is a way that we can, from this application on the mainframe, send some sort of a proactive alert. So instead of running a bot that spins out into tens of thousands of transactions potentially, and again, you can see all the activity that this is happening. The idea is to be able to show the DNA specifically enough so an organization can understand what the problem is, what the business requirement is, and then potentially conceive of solutions. Now, I'll go back to this top level dashboard, and I'd like to show you a little more about our RPA signature analysis. Now, we use this Pareto chart to help us focus on what really matters. In other words, what users, this operator ID field, what users, how many users do we really need to focus on in order to get to the 80% activity level? Well, it turns out maybe no more than 8. How many network endpoints do we really need to focus on to get to the 80% activity level? Well, it turns out there's only 7. How many signatures do we really need to focus on to get to the 80% activity level? Well, it turns out there's 7. Now, we've already seen what this one is. This is the most active signature. And as soon as it comes up, you'll recognize it. It was the one that we just looked at. Well, I take that back. It's the most active signature. This is, let's search over here. The most active signature is one that is all wrapped up in the order processing process. So the single most active signature has a common DNA of running ORR and then running ORC and then working back and bouncing back and forth between ORR, ORC, and a transaction called ORCA. So we can know, okay, that is the business process that really is the most active signature. And then we can go down and look at the one that is the second most active signature. And again, we'll wait here just for a second. Okay, so the second most active signature was in fact the one we looked at. So here's the ORR transaction and scripts or bots that are beating on the enter key. And here's the one where we see, very high volume. And then we can just work our way down. And again, the good news is that, and we see this at many organizations, and the way we put it is this: you don't need to boil the ocean. In other words, you don't need to fix everything. All you need to do, and what the tool is intended to show you, is what are the things that are really worth your time and will give you a good, solid payback for your efforts to go improve these integration scenarios. So here's another. Here's the third most active scenario, where we're going from ORR back to the menu, back to ICIS, back to ICIS again, back to ORR. So again, all of this is just meant to help our customers focus on where the problems may be. I always like this one because we get down to CPU time by signature. So what is the top? I think we know the answer to this. Where are we burning the most CPU time in with these sorts of automations? Well, it's our good friend, the enter key, and some sort of a script that is beating on the enter key, waiting for status changes related to orders. Now, I'm going to switch customers here. And let's get over here to a different customer. Now, this is a smaller customer, both in terms of organization and in the amount of data that we have. But the dashboards work the same way. So we're gonna pick the highest hour, and then let's come over here and we'll pick the highest minute within the day, and we can come down. Now, again, what we're going to see is something very different here. This is a whole different customer, different applications. Now, with this particular customer, all their most common transaction is labeled DIMS. Well, showing a DNA that just said DIMS, DIMS plus the clear key, DIMS plus the enter key, that would not have been very interesting. So what we've done here is we've established the context within the application by showing you the BMS map set and the BMS map name that the Excel macro or the bot was using. So this again gives us a little more information. So at this customer, what we extracted as part of the metadata was that BMS map or map set name, so that we can establish what's really going on. Now, and then you can see the DNA. Now, I always like to use this particular customer and this particular DNA to highlight something. Now, before I highlight that, I'm going to go back and do a little bit more analysis and say, where is all of this automation activity coming from? And so we look at the RPA signature analysis panel, and we say, we'd like to see the total signatures per client IP address. Well, look at that. There are only 2 IP addresses. I mean, just the first one almost gets you to the 80% level, but there are only 2 meaningful IP addresses that are driving this workload. And in fact, if you look at total executions per signature, there is one signature coming from those two endpoints that is driving everything. Now, what are these two endpoints? These are two different servers running an IBM software product called HATS, the Host Application Transformation Server. HATS is, for lack of a better phrase, and I don't mean this too negatively, it is the mother of all screen scrapers, right? It is a platform, it is a tool that lets you create a whole alternative user interface on the top of 3270 based applications. So you can completely change the user interface, and then HATS on the back end will essentially drive the 3270 transactions, drive the Kix transactions, screen scrape those transactions, and then represent that data. Well, I say all that to point out a problem with those platforms. I mean, it's problematic enough that this organization is still achieving integration using terminal emulation and screen scraping. But frankly, what's more problematic for this organization is how these macros were written. Now, I don't know about you, but if you've had any experience in the Kix world for very long, you might look at that pattern of DNA and wonder, I wonder why they are pressing the clear key so many times. In fact, when we did the analysis of all of their mainframe interactions, clearly 50%, 50, of all of their interactions between HATS and the mainframe were nothing more than a HATS macro pressing the clear key. Well, that seemed very, very odd, not only to the mainframe people who knew this application very well, but also to me kind of looking at it at the 30,000 foot level. And so we called the team that wrote the HATS macros and said, can you help us understand why you are using or sending in requests to the mainframe, pressing the enter key on the DIMS transaction so often? And the answer was, well, we're really not mainframe application people, but we were told that if we're ever in doubt about where we are within the state of this application, all we need to do is send in a clear key and we'll get back to a home screen, and from there we can run a transaction. It's like, oh, okay, I get it. So now with that bit of information, right, which wasn't wrong, they then codified that in their HATS macros, such that now what is the most common interaction between HATS and their mainframe? It's pressing the clear key, which absolutely adds no business value. So I kind of had an interesting phone call with this customer one day where I had to tell the deputy CIO that, based upon our analysis, part of the reason your Kix regions are eating your mainframe alive is the fact that fully 50% of all of the interactions between HATS and your mainframe are interactions resetting the state of the application. In other words, pressing the clear key, and they have no functional purpose and they create no business value. So if this macro can be remediated, you stand the potential of reducing your Kix transaction load from HATS by 50%, 50. Now, I can't say that at your organization we'll find that level of immediate impact or not. But what I can say is that every time we look at sets of data from various customers, we find something along these lines. Now, again, we're just focused here on bots, macros, or screen scraping scripts that have probably been running in your organization for a long, long time. But our objective is to let you see the forest for the trees and then help guide our customers to where they can get the best bang for the buck. In other words, you don't like, and I always go back with our customers and say, you do not need to boil the ocean, I promise you. But you will have no more than 6 to 8 problematic integrations that if you will correct, you will be much better off and you'll save a lot of operational overhead and CPU time. Now, I get pretty excited talking about all of this, but I would like to save a little bit of time for questions at the end. So let's just move on and begin to wrap up. Based upon our work with customers over the past few years with this tool, developing it and using it to analyze their data, we have seen 3 top causes for poor integration performance. One is the one we've just camped on, screen scraping and terminal emulation-based interfaces. And doing all this orchestration and automation from whether it's a screen scraping gateway or client or RPA platforms. It's a problem. The other one, number 2, we see are implementation-based APIs. In other words, we were looking at some data from a bank. Now, they don't, their problem with integration is not related to 3270 or CICS terminal-oriented transactions. It's the fact that they are using a platform off the mainframe that they consider to be their enterprise service bus, and they are sending in discrete HTTP requests to execute individual COM area programs. And they are doing this using a very implementation-specific API. But it also exemplifies number 3, which is they're doing a lot of external orchestration of mainframe requests. Now, let me peel the onion just a little bit deeper, if I might. Screen scraping gateways like HATs or products like HATs, such as Legacy from Rocket, they typically run a lot of transactions that are really unrelated to the business processing requirement. It's exactly what we saw where a macro was written. And what did it do? It pressed the clear key between every meaningful step in the business process. And it was not operationally necessary. It was just a giant sucking sound on their CPU. But likewise, those sorts of screen scraping macros and bots can be running on a client. And when these screen scraping macros and scripts really start to get active in the heat of a processing day, they create, for lack of a better word, a denial of service attack. I mean, if we saw this pattern of interaction in a security context, where you have an endpoint beating on the enter key every 200 milliseconds for 20 minutes, we might be tempted to call it a denial of service attack. But in this context, it's kind of a sanctioned attack. We're letting it happen because a lot of times we didn't even see it. We didn't know it was happening. Now we can at least know it's happening. But then we need to find remediations. And we'll talk about remediation strategies in a minute. But that's really important to be able to see these things. External orchestration, our view is that orchestrating fine-grained apps and data, and by fine-grained, what I mean are fine-grained steps in a transactional process or accesses to data that take microseconds or at most milliseconds. If we're orchestrating that across a network using an endpoint on sometimes the other side of the country or the other side of the world, you end up with this tremendous accumulation of latency. And that results in tremendous hit on end user productivity. It also drives up mainframe resource utilization. And we'll be talking about that in a subsequent webinar we'll talk about in a minute. But also we like to highlight what we call technology-based APIs. APIs that expose implementation details have some problems. They may have been good a decade ago, but with hindsight as our instructor, we can now see that these sorts of technology-based APIs that expose implementation details, they tend to inhibit modernization objectives because the two endpoints are all tangled up based upon the incumbent implementation of a business process. And they also tend to increase mainframe request volume. So we could say a lot more about each of those categories, but for the sake of time, let's shift over to remediation. There are many remediation options, and I'm just going to go ahead and put them up here. Sometimes we look at these, we look at this data with customers, and what the data says is that they really need to go fine tune or just do some tuning in and around Kix or their Kix applications. We have a number of customers who are contemplating rebuilding their application catalog or inventory, set of applications using the COBOL version 6 compiler. But they tend to approach it as, well, we need to do it all at once. Well, maybe not. What if you use the data and the screens that we showed you on those dashboards to be able to say, well, your most frequently used transaction is ORR, and it's tangled up in the most bots and macros. Why don't we do that first? So in other words, using the analytics to point us to where we ought to do the tuning, not just globally in the Kix environment, but even down at the application level. It can also point out where organizations want to modernize or refactor their apps. If you reflect back on some of that DNA, I mean, those macros at one customer was always going from transaction A to B to C to D to E. Well, if that is the most common pathway through that application, maybe a bit of refactoring could be done. Instead of that being 5 steps, 10 steps, or 1,000 steps, maybe that's worth our time to refactor that application in some way. Also, we can look at the integration architecture. This is a category that we love simply because we, in our other part of the company, we put forward a product called our HostBridge JavaScript engine. And HBJS is a tool that allows you to create and expose higher level APIs and leave all the orchestration of the underlying apps and data on the platform, which is far more efficient in both in real time and CPU time. But sometimes it just boils down to needing to address the business process. I'll never forget one day, it was about 2 years ago, I was talking to a customer and I was showing them their data, and I postulated a solution for a particular bot, a technology solution. And the person on the other end kind of chuckled and said, "Oh no, Russ, it's far simpler than that." And I said, "Oh really? Great. What is it?" He said, "All I need to do is pick up the phone." I said, "Okay, tell me more. Now I'm interested." He said, "Yep, all I need to do is pick up the phone, call the vice president of sales for Europe. Apparently they did not get the memo or did not read the email that we augmented this whole new business process. They don't need to run this macro every day, every morning at every desktop. Instead, they need to log on to our SharePoint portal, click on a PDF and they'll have it instantly. So again, large complex organizations, not everyone reads their email, not everyone is using what you hope are your most common and efficient business processes, and having this data lets you see that. So let's wrap up. We'll go back. We've talked a lot about identifying inefficient patterns of integration, and then evaluating those. And what we're doing, kind of some of the things that we're doing in our dashboards today are helping you analyze that, not only in terms of their impact, but also their CPU time. We're now starting to toy around with, or not just toy around with, actually implement the knowledge into our dashboards to help you really understand how many MIPS are these bots really costing you. In other words, wouldn't it be great if we could not only show you what the worst case offenders were in terms of these scripts or bots or macros, but also show you in aggregate how many MIPS they're costing you, what your saving potential might be. And then, of course, we want to help. We offer certain tools to mitigate these sorts of inefficient automations, particularly what I mentioned was our Hostbridge JavaScript engine that runs on the mainframe, under Kix, and on the zip engine, if you have one. But it's certainly not the only mitigation strategy. So our job is to help you identify, give you the data to evaluate, so you and others in your organization can take the correct mitigation steps. Along those lines, I'll point to a couple of resources. First of all, we're going to be, we've already scheduled another webinar out in September. We're going to talk about 3 strategies to resolve these sorts of integration performance challenges. And we'll be highlighting HBJS in that and talking about other mitigation strategies as well. Also, I would point you to, as resources, a number of videos that we've just recently put out. You can find them at hostbridge.com/videos. That's kind of our video channel. You can also find them on our YouTube channel. And they provide a lot of high-level, quickly, easily digestible information about our thinking when it comes to identifying problematic integrations and then solving those problems. Farrell, why don't I stop there? So we can allow a few more minutes, for Q&A, and let everyone have their day back.
Thank you, Russ. I just posted in chat, direct message to you, a few questions we got as you were presenting. And then if our audience wants to ask a question by phone, just raise the hand or use the question hand option, and then I'll unmute your phone.
Okay, I'll go through these. Let me start at the top. Question number 1, we have many, possibly hundreds of discrete macros and bots interacting with our mainframe apps. How precisely are you able to identify those specific ones that are problematic? Well, maybe we've already covered some of that. First of all, how precisely, as in, we can tell you down to the transaction name, the AID key that the bots and the macros are pressing, the BMS maps that they're interacting with. We can show you the exact, precise DNA of that activity. We then create a signature for that activity so that we can show you longitudinally or over time exactly how often that pattern of integration is being used and whether, honestly, it's worth your time focusing on it. That's really the key. So how precisely, so if I highlight the second part of the question, can we identify those that are really problematic? Absolutely. Whether your definition of problematic is transaction volume, whether the definition of problematic is CPU consumption or real-time duration or latency or end user performance, perceived performance problems, we can show you all of those. Let me see, number 2. We have been doing some of the things you discussed for years, such as end user developed macros to get data off the mainframe. It seems to be working. Why should they or we attempt to move them away from this type of access? Isn't this a situation where if it ain't broke, don't fix it? That's a great question. And the fact is, there are some macros that are running in your organization that don't represent a problem. They just don't. But I think we've shown, or at least I hope we've shown, that in your organization, if the highest consuming CPU bot is something that presses the enter key up to 10, we've seen cases of 20,000 times every 200 milliseconds, waiting for some sort of a state change to occur. I think we can all agree that that's worth a little bit of thought, that it's not worth all the resources, the operational issues on the back end to solve that business requirement that way. So I believe that there are a lot of use cases out there of macros where it's not worth fixing. But the data suggests that there are many, at your organization, if you are doing a lot of this, I promise you, we can find 8 to 10 that I think if we sit down and look at the consumption and what's happening, we would both agree there's got to be a better way to meet that business requirement than driving the back-end transaction volume through the roof. Number 3 question, what has to change in the middle tier to provide or to facilitate this analysis? That's easy. Absolutely nothing. There are absolutely no middle tier changes need to occur. And I'll go back to a slide that I was looking at earlier, this one, and that is that nothing needs to change on the left side of this diagram. Nothing needs to change with respect to your web servers, HAT, CTG, app servers, whatever. Nothing changes. What we do is, again, all we're doing is we're adding a few exits into your Kix environment. You can run them all the time. You can run them just in targeted times during the day, your choice. And we're gathering little bits of metadata about each and every one of those requests. We are causing that data to be added to the SMF 110 records in the origin association fields. We're not even adding any new fields to your SMF 110s. But once we have augmented, or as we say, enriched those SMF records, we then move that down to a proper analytics platform for analysis. Bottom line, nothing changes in your distributed world. Farrell, that's all the ones that I see here. Any others come in?
Nope. Nobody raised their hand to ask additional questions. So we're also coming right up on our scheduled stop time. So I want to thank everyone for carving out time of your busy. We know everybody's schedules is super busy these days, but we appreciate you giving us some time to allow us to talk about what we believe is a very important issue and ways to identify, and then a follow-on webcast about remediating these troublesome issues with mainframe integration. We did record the webcast, and we will email a link to the recording to you. It's also will be available on our YouTube channel as well as our website video section of our website. Please do check that out. That's a new feature we just added, and I think you'll find it very interesting. Russ covered a lot of territory in a very short amount of time today. If you have questions, or if you would like to schedule a free analysis, _free, of your macro script bot app interactions with the mainframe, please just contact us. With that, thank you for attending, and this will conclude today's HostBridge webcast.